Welcome to Foundations of Computer Networks. We are at session 10, and this is where we start to look deeper into the whole aspect of subnetting. Before we do that, however, just to remind you that your ability to communicate in binary information and to convert from binary to base 10 and from base 10 back to binary is going to be extremely important. So let's jump into what we want to look at. Originally, IP addresses were organized in terms of classes. And we have from class A to class E. This is important to understand because when we look at an IP address, we should be able to know instinctively which one of these classes the IP address falls into. And we can know this because the IP addresses are organized in terms of different ranges. So for example, a class A address is going to range from 0 to 127. A class B address is going to range from 128 to 191. And a class C address is therefore going to range from 192 to 223. Now you might be asking yourself, how do we come up with these ranges? So there's some method to the madness. And by the way, we are only focusing on class A to C because those are the ones that are going to be usable. So we were just talking about how do we know or how do we derive these numbers or these ranges that the IP addresses are going to fall into for each of these classes. And we do that by laying out the bits. So we have the 8 bits, and then we are going to apply some special procedures to these bits, and that will allow us to know the range. So let's see how that is accomplished. First of all, please note that there is this section that talks about higher order bit. So that's the HOB, the higher order bit. And for class A, B, and C, please understand that each of them come with different patterns. So for class A, we only set one higher order bit, and that's going to be set to 0. For class B, we are setting 2 higher order bits, and that is being set to 1 and then a 0. And then for class C, we are setting 3 bits, and those 3 bits are now going to be 1, 1, and 0. So these patterns are going to be standard for class A, for class B, and for class C addresses. What does this mean? This means that if, for example, I see an IP address and it is laid out in terms of bits, and we're just looking at the first octet, by the way, the first 8 bits. And if it looks like this, 110 0 0 0 1, if it looks like this pattern, then instinctively we are going to know that it is a class C IP address. Why? Because we are going to look at the first 3 bits, look at the pattern, and when we look at the pattern for the first 3 bits, that pattern is going to match what the class C expects, which is 1, 1, and a 0. Now, how do we know that this 1, 1, 0, if the binary digit, talking about the 8 bits, if it begins with 1, 1, 0, how do we know that it therefore means that the start of the range is going to be 192. Well, let me copy this. Let me go over here. And let me get rid of the final 0. Sorry, the final 1, and replace it with a 0. So we're just looking at this. We know it starts with 110, which means that it fits into the class C pattern. So what is that 110 going to be equated to? Because remember, this is an 8-bit pattern, and it therefore means that everything else is going to be set to 0. So what it means therefore is that we have turned on the first 2 bits out of the 8 bits. So looking at our table, we have bit 0 running to bit 7, that's 8 bits, and we have turned on the first 2. So the first 2, seeing that it's turned on, it means that we have one group of 128 and we have one group of 64. And if we add that up, so that's 128 plus 64, then we end up with 192. And that tells us that the range will begin at 192. Let's try something else. Let's assume that we see this pattern. So it's 1 0, and then the rest of things are going to be 0. And we now want to compute this. And we're asking ourselves, therefore, what range does this fall into? And if we compute this, then it means that we only have one group of 128. So it therefore means that we're looking at 128. And if we go back to our table and we look at 128, we realize that that is a class B address, because the class B address begins at 128. So we have just computed the starting range for the class B address. So the key point to note here is that the higher order bits are set. They are predetermined for the class A, B, and C addresses that we are going to be using. So that's one thing to understand. The other thing that we want to understand is that, and we have said this before, the subnet mask will allow us to know how many bits are associated to the network portion. In other words, how many bits will determine the network ID. And for a class A, that's going to be 8 bits. For a class B, it's going to be 16 bits. And for a class C, it's going to be 24 bits. So we are talking about the first set of bits, or the first set of high order bits that we're going to have. So the first 8 bits, they are going to be used to represent a class A address, which means we're going to turn on all of those bits. And that is why our subnet mask becomes 255, because it means that for the subnet mask, we would have 1111, 1111. And if we compute what this equates to, then you will realize that we have turned on all the bits going down, all 8 bits. So it therefore means that this is going to be equal to 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And when we do the computation, we end up with 255. So once we see the decimal number 255, we therefore know that if we convert it to binary, it's going to be 8 ones. So going back to what we were saying, for class A, we know that 8 bits are associated to the network. For class B, 16 bits are associated to the network. And for class C, 24 bits are associated to the network, or these bits are used to represent the network. Now, there is another way that we can represent this without having to explicitly write out the subnet mask. And this is known as CIDR notation. And note, CIDR notation uses a forward slash followed by the number of bits which are associated to the network. So /8 tells us that 8 bits are being used as network bits. /16 tells us that 16 bits are being used as network bits. And /24 tells us that 24 bits are being used as network bits. So note, we can easily switch between CIDR and subnet mask if we know what we are doing. Because 255.0.0.0 means 8 bits are associated to the network. And if we have 255.255, then that tells us that we have two groups of 8 bits being associated with the network, which give us /16. And if we look at 255.255.255, that tells us that we have 3 groups of 8 bits. So 8 times 3 give us 24. So you should now be comfortable in terms of moving between CIDR notation and subnet mask. The other thing that we want to bear in mind, apart from the network bits, is how many bits are associated for the host. And right here in this graphic or this image, we're indicating how many octets are being used for host and how many octets are being used for the network. So for the class A address, we are using 1 octet to represent the network, and we are using 3 octets to represent the host. So in terms of the number of bits which are associated with the host for a class A address, it's going to be 8 times 3, which gives us 24, which is the same value that we're seeing here. So important to note, the total range of octets that we have is 4. So 8 fours is 32. So therefore means that if 8 bits are associated to the network, then it means that 24 are going to be associated to the host. And that's what we have just demonstrated or illustrated here. And if we move to 16 inside a notation, then it means that 16 bits are going to be associated to the network. And therefore it means that 16 bits are associated to the host. Because once again, everything must add up back to 32 in terms of the number of bits. And if we look at the class C, then we know that 24 are associated with the network. Alright, so something is wrong here. Let me change this quickly. So that is N and this is N. So therefore means that 8 times 3 is 24. So 24 bits are associated to the network. And 8 bits are going to be associated with the host. And that's what is being demonstrated by the table that we have in this section. Now another thing that becomes important is, where does each range start and where does it stop? Well, where it starts is easy, because for a class A address it starts at 0, and if we look over here, notice it says 0 to 127. And if we look here, this says it starts at 128. And if we look here, then this says it starts at 192. So the starting points are going to be easy to understand. And once we understand the starting point for each range, then we know what the ending point for the previous range is going to be. Because it's going to be maxed out by 255 going down. So it's going to be the end of the range. So the end of the range here is 127. And then all the other octets are going to be 255 because we're filling out the bits and turning all of them on. Now, there is also the issue of how do we compute number of networks and how do we compute number of hosts. And we are going to use the formula 2 to the n, where n represents the number of bits. So for the number of networks for class A, it's going to be 2 to the 7. And you might be asking yourself, why is it 2 to the 7? And it's 2 to the 7 because we know, or we have already said, that for a class A address, the higher order bit must be set to 0. So because that higher order bit must be set to 0, then it means that all the other bits that we have will be 7 if we total them up. Because we're working with an octet, which is 8 bits. If we use one of that bit to represent the 0 for a class A address, then it means that we are left with 7 bits. And if we are left with 7 bits, then it's 2 to the n or 2 to the 7, and that gives us 128. So that's what we are seeing being displayed here. So the number of networks that we can create is 128 networks. For a class B address, how many networks can we compute? Well, it's going to be 2 to the 14. And you might be asking, why 2 to the 14? And the answer is simple. We know that for a class B address, 16 bits are associated to the network. However, out of those 16 bits, we have already indicated that 2 bits are already predefined. So we can't make use of those 2 bits. So it therefore means that what we are left with is 16 minus 2, which gives us 14. So then we end up with 2 to the 14, meaning that we can create 16,384 networks. And finally, for class C, 3 bits are being used out of 24 bits. So if we use 3 bits out of 24 bits as predefined use, then it means that we are left with 21. And 2 to the 21 will give us about 2 million networks. The final thing on this that we want to look at, because we will be revisiting this table, the final thing that we want to look at on this page is the fact that in each class of IP address, there are some addresses which are called private IP addresses. And what this means is that we are free to use them internally within our networks. So you need to become comfortable with these ranges, because as you see these ranges, you should instinctively know which class of IP address we are talking about. So the private range, the ones that can be used within our networks, or to just elaborate further, the ones that we can put on devices within our networks without having an issue, are going to be, for class A, it falls within the 10 range. So anything that begins with a 10 is going to be a class A IP address. For class B, anything that begins with 172.16, that is 172.16, anything that begins with that, then potentially it is going to be a class B address. And why I say potentially is we have to look at the ending. So it says 172.16.31.255. So that's the total range, which means if we go to 172.16.55.255, then that would be outside of the range of the private address range for a class B address. Let me just type that so you can see what I was saying. So 172.16, and I said 55.255. Just looking at this, it means that it falls outside of the range, because the range ends at 172.16.31, and this is .55. And for the class C address, anything within the 192.168 range is going to be a valid IP address that we can place on our devices within our private networks. So that is it in terms of this kind of introduction and what the table brings to the party. And in the next section, we'll now start talking about subnetting, and we'll be tying back subnetting, what we are doing in terms of that process, with what is happening here in this diagram.